Alright, time for a quick lesson on analyzing histograms. So basically this assignment is, hopefully you already know how to make histograms, and now you're just reading them and interpreting the sort of things that are in there. So kind of an introductory question is, if you look at these histograms right here, you can visually see that their means are going to be different. The mean, right, the average, if you look at this bottom one, it's probably going to be down here-ish, kind of in the middle of the data there. And if you look at the top left one, it'd be more towards here, and then the top right one would be somewhere here in the middle. All right, and these are just guesses. I'm not saying like that's the exact mean or anything, but that's roughly where they would end up. And you can see that in the histograms when you can just see, is it more to the right or more to the left, because the mean's usually in the middle. The mean and median are usually kind of close to each other unless there's some outliers. And that brings us to these questions here. See how many batting titles were won from 1901 to 1930. So you got to go back to this guy here, and you go between these here, and you just count it up. You just count how tall these are. Like that's 1 tall, that's 4 tall, that one's 6 tall, that one's 2 tall. Add them all up, you get 13. So I put 13 here. Alright, and then you go on to the next one, same thing, but on the next graph. So I go between here and here. This one's 1, 6, 4, and then 13 up there. Add that up, you're looking at 24. Oops, that's bad, 24. And then the next one, our last graph, which is actually right here still. You can count how tall these are. This one's looking about 11. This one's probably 18, 19. Let's say 18. And this one down here about 6. This one's probably 3 and then 1. Adding that up, you're looking at 21, 28. Sorry. Hold on. 21 plus 18. You're looking at 39. About 39. Again, sometimes you can't see the individual tick marks, but you get the idea. And so there you go. If you were to find the mean of each winning batting average for each period of time, which period do you think would have the highest mean? And we already looked at that up here when we were looking at these graphs. Kind of erase some of these lines. We kind of noticed that this one would have the highest average, and then this one is the next lowest, and then this one. So it's looking like the top left one, that's 1901 to 1930. On to 1930. And you need to provide an explanation as to why. It can be just as simple as like it has has taller bars farther to the right. And that's what would show you that the data is more data's to the right, and it's higher, right meaning higher. And so there you go. This is kind of a quick explanation. You kind of say some things about the graphs. And then this one, again, I'm just going to say it in words rather than write it all out for you, but you can write this down in sentences. As the century progressed, what in general happened to the batting averages of the batting title winners? Well, they went down. If you look at these graphs here, this is the earliest, and then the next one, and then this is the most recent one. The means kind of slowly go down, and so that's what I write down. They would lower. We can visually see that the bars are becoming less tall on the upper end of it and becoming more tall in the middle, and then down towards the bottom end of the graph, the left end of the graph. And so that's what you write down here for your answer and provide an explanation. So yeah, so this kind of introduction to reading histograms. You got to look at it, figure out how tall things are, and all that. A few things you need to know is the difference between discrete and continuous, and this will show up in the assignment. Discrete data sets are not connected, and usually they only take on specific values and can't take on all the in-between ones. For example, like number of people would be a discrete amount. You don't have like half a person in a particular room or half a person at a school. You count a whole person, and even if they're missing limbs and stuff, it's still a whole person. We don't discount someone because they're a different size or missing pieces. Okay, that's discrete. Whereas you can have continuous amounts. That's things like temperature, how much you weigh, how much you think I could spell, how much mass something has, how tall you are. Right? You can have all the in-between values. If you're looking at a graph, it's connected. If you're looking at a graph here on the discrete one, it's individual points that you actually can't connect. So there's a couple of differences there. And there's a difference between quantitative and qualitative data. Quantitative, like quantity, is a number of something. That's usually what we deal with in all of these lessons and stuff. In stats there's groups of numbers, data sets. That comes from quantitative data. Qualitative data kind of deals with qualities of things. Spelling. There's like if something's blue or red, if something is from Utah, if something is from Germany, those would be qualitative things, words that describe things. And man, my handwriting is getting atrocious. Like it's words, and quantitative is number of things. For example, letters per word, that's a quantitative amount. Our sleep times, like how long someone slept, that'd be quantitative. Which data set is continuous, which data set is discrete. Well, if you have letters per word, a word can't have half a letter, and so the letters per word would be discrete. Here, I'm going to just draw a circle. Like letters per word would be discrete. But sleep time, how long you sleep, you can get down to really minute measurements, and so that would be a continuous type of data. So there you go, kind of a quick lesson on those sort of things.